Okay. So, good evening. This is the third practice session of the course Geotechnical Engineering 1. The topic of this session is soil structure, soil classification. Uh, like the previous classes, also this class will have a set of questions which will comprise of multiple choice questions. It might also have multiple select questions, true false statements, and some numericals. So I will first start with dictating the questions. I think this module has a set of approximately 18 to 20 questions. I think so. I'll start dictating the questions, and I need you to write down the questions as I dictate them. Okay. And for the numericals, please write down the data very carefully. I hope you are sitting with your calculator along with pen and copy. So I'll dictate the questions. You will write the questions down, and then I'll give you some time, approximately 10 to 15 minutes. I'll give you some time to solve those questions. So please do not tell the answers if other people join this meeting. Do not tell the answers or write the answers in the chat box while I dictate them. Okay, you solve them on your time when I give you the time. After the time I give you for solving these questions, in the same meeting only, don't leave the meeting, I'll start discussing the solutions, okay, for all the questions. In that time, at that time, when I start discussing the solutions, you can tell the answers, and if you're right, then we'll discuss together. It will be an interactive session. Okay, so I hope I was clear. So I will now start with dictating the questions. Okay, so I hope the PPT is visible. Yeah. So again, this is the third live session of the course Geotechnical Engineering 1, and the topic of today's problem solving session is soil structure, soil classification. So the first question is, in case of silts, the following type of soil structure is exhibited. In case of silts, the following type of soil structure is exhibited. Your options are flocculated, dispersed, honeycombed, or single grained. I hope you are familiar with these terms: flocculated, dispersed, honeycombed, single grained. Please write down the questions along with the options. I repeat the question. In case of silts, the following type of soil structure is exhibited. The options are flocculated, dispersed, honeycombed, or single grained. Someone is joining now. Okay, so someone has joined recently, just now. So please Write down the questions. I'll wait in. This is the first question, so no need to worry. And please mute yourself. Samit Injay. Yes, thank you. So I am currently dictating the questions. Okay. Please write down the questions along with the options. After dictating the questions, I'll give you time to solve, and then after that I'll start discussing the solutions. So please do not tell or write the answers in the chat box while I dictate the questions. Let others also solve them. Okay. So this is the first question, and the question is, in case of silts, the following type of soil structure is exhibited, and the options are flocculated, dispersed, honeycombed, or single grained. Flocculated, dispersed, honeycombed, or single grained. I hope it was clear. I'll go to the next question right now. Yes. The second question is, the biggest size of a clay particle is. The biggest size of a clay particle is. Your options are 0.003 millimeter, 0.002 millimeter, 0.0002 millimeter, or 0.075 millimeter. I repeat the question. The biggest size of a clay particle is. The options are 0.003 millimeter, 0.002 millimeter, 0.0002 millimeter, or 0.075 millimeter. Okay. So next question. Yes. Silty clay indicates. Silty clay indicates. The first option is silt percentage is less than that of clay. Second option, silt and clay particles are in equal proportion. Third option, silt percentage is more than that of clay. Last option, none of these. I repeat the question. Silty clay indicates silt percentage is less than that of clay. Silt and clay particles are in equal proportion. Silt percentage is more than that of clay, or none of these. Okay. I hope the question was clear. Next question. Yes. Sand particles are made up of. Sand particles are made up of. Your options are kaolinite, illite, rock minerals, or all of these. I hope you have heard the terms kaolinite and illite. You know rock minerals. I repeat the question. Sand particles are made up of. The options are kaolinite, illite, rock minerals, or all of these. Next question. Among the given soils, the specific surface is the highest for. Do you know what specific surface is? Do you have any idea what specific surface is? Okay, let's keep this for the discussion part. Read on the question now. Among the given soils, the specific surface is the highest for. The options are sand, silt, gravel, or clay. Someone has joined now. Please write down this from this current question. I believe you have missed the first four questions. I can do a quick recap after I finish dictating all the questions. Okay. Please write down the questions. Okay, another one is joining. Please write down the questions. Please mute yourself. Dilshit Narayanan, please mute yourself. Hello, Dilshit Narayanan, please mute yourself. Yes, please write down from the current question Okay, you have missed 4 questions. I can do a quick recap after I complete, dictating all the questions. This is the fifth question, I believe. Yes. So the question was, among the given soils, the specific surface is the highest for. The options are sand, silt, gravel, or clay. I hope the question was clear. I'll go to the next question. Yes. Adsorbed water on a soil particle imparts. Adsorbed water on a soil particle imparts. The options are friction, plasticity, shear strength, or none of these. I hope you are familiar with the terms friction, plasticity, and shear strength. I'll repeat the question. Adsorbed water on a soil imparts, on a soil particle imparts. The options are friction, plasticity, shear strength, or none of these. Okay. Okay. Next question. If you have any doubt regarding understanding a particular question, you can unmute yourself and you can ask, or you can raise a hand. Okay. Next question. Yes. BIS, that is the Bureau of Indian Standard, soil classification is based on. BIS soil classification is based on. The options are grain size distribution. Option 2, plasticity properties. Option 3, both of the above. Option 4, none of these. I'll repeat the question. BIS soil classification is based on. BIS soil classification is based on. The options are grain size distribution, plasticity properties, both of the above, or none of these. Okay, just a moment. Yes. Okay, next question. Yes. Boundary classification is to be resorted for coarse grain soils when the percentage fines is. Boundary classification is to be resorted for coarse grain soils when the percentage fines is. Option 1, greater than 12 percentage. Option 2, less than 5 percentage. Option 3, between 5 percentage and 12 percentage. Or option 4, none of these. I repeat the question. Boundary classification is to be resorted for coarse grained soils. Someone has joined now. I repeat, please write down the questions from the current one. I'll give you some time to solve them. Okay. And I will start discussing after a while. Please write down the questions from the current question. This is the 8th question. Okay. Okay. And please try to join from 6 p.m. because the class actually starts from 6 o'clock. So it will be good if you all join at 6 at the right time. Okay. So I repeat the question. Boundary classification is to be resorted for coarse grained soils when the percentage fines is. The options are greater than 12 percentage, less than 5 percentage, between 5 percentage and 12 percentage, or none of these. Okay, I hope the question was clear. I'll go to the next question. Okay, this is a true false type of problem. The statement is organic soils have a color of dark blue to ochre. Organic soils have a color of dark blue to ochre. Is this statement true or false? I repeat the question. Organic soils have a color of dark blue to ochre. Is this statement true or false? Okay. So next question, I'll go to the next question. Yes, the soils which plot above the A line in the plasticity chart are the soils which plot above the A line in the plasticity chart are. Your options are inorganic clay, silts, organic clay, or organic soil. Rajol Sare, you have joined late. I have to repeat this for every people who are joining because they should know the rules. Like you have to first write down the questions, okay, as I'm dictating them from the current question. And as I think three people have joined after the scheduled time, I will not be repeating the questions because one person have missed I think four questions, another one has have missed seven questions, and now the last person who has joined the class, uh, I think you have missed 10 questions. So I will not be doing a recap of, of the questions after I dictate. So you need to write down the questions from the current one. I'll give you some time to solve them, okay? And when I start discussing the solutions after that break, then you can write down the questions and the solution all together. Is it okay? Yes, I couldn't hear you. I think there was a connection issue. You can mute yourself anyway. Yes, please mute yourself. Rajol Sare. Okay. So this is the question. I believe you are familiar with the terms plasticity chart and A line. So the question is the soils which plot above the A line in the plasticity chart are. Your options are inorganic clay, silts, organic clay, or organic soil. I believe there is no doubt regarding the questions till now, because if you have, you can speak up, okay, in understanding the questions. So this was the, I think, 10th question. The soils which plot above the A line in the plasticity chart are inorganic clay, silts, organic clay, or organic soil. I'll go to the next question now. Yes, this is a numerical. Please write down the data very carefully. There are a few over here. A soil has liquid limit of 20 percentage and plastic limit of 14 percentage. As per IS, this Indian Standard Classification, the soil is, the options are inorganic silts with high plasticity. Option 2, organic clays of medium to high plasticity. Option 3, inorganic clays and silts of low plasticity. And option 4, inorganic clays of medium plasticity. I repeat the question. A soil has liquid limit of 20 percentage and plastic limit of 14 percentage. As per IS classification, that is the Indian Standard Classification, the soil is option 1, inorganic silts with high plasticity. Option 2, organic clays of medium to high plasticity. Option 3, inorganic clays and silts of low plasticity. And option 4, inorganic clays of medium plasticity. I hope the question was clear. I have the plasticity chart over here. I'll show you while solving this question. Okay. Next question. Again a true false question. The statement here is, if the soil retained on 75 micron sieve is more than 50 percentage, the soil is fine grained. So is this statement true or false? I repeat the statement. If the soil retained on 75 micron sieve is more than 50 percentage, the soil is fine grained. Is this statement true or false? Any doubt regarding this question or any other questions before? Anyone? I believe your voice is not reaching me. You can
No, no,
just,
sir.
okay, okay, fine, fine. Okay. So the statement I'll just repeat once. If the soil retained on 75 micron sieve is more than 50%, the soil is fine grained. Is the statement true or false? You have to answer. Okay. So next question. Yes. The phenomenon of regaining lost strength with passage of time under constant water content is called. The phenomenon of regaining lost strength with passage of time under constant water content is called. The options are sensitivity, thixotropy, liquefaction, or activity. I will repeat the question. The phenomenon of regaining lost strength, of course, here I'm talking about soil. Okay. The phenomenon of regaining lost strength with passage of time under constant water content is called. The options are sensitivity, thixotropy, liquefaction, or activity. I hope the question was clear. I'll go to the next question. Yes. The predominant mineral responsible for shrinkage and swelling in black cotton soils is, I repeat, the predominant mineral responsible for shrinkage and swelling in black cotton soils is. The options are elite, montmorillonite, halloysite, or kaolinite. I repeat the question. The predominant mineral responsible for shrinkage and swelling in black cotton soils is. Your options are elite, montmorillonite, halloysite, or kaolinite. I hope the question was clear. I'll go to the next question. Yes. A soil has a liquid limit of 30 percentage. The corresponding plasticity index given by the A line is. A soil has a liquid limit of 30 percentage. The corresponding plasticity index given by the A line is. The options are 14.6, 7.35, 7.30, or 9.3. I repeat the question. A soil has a liquid limit of 30%. The corresponding plasticity index given by the A line is, your options are 14.6, 7.35, 7.30 or 9.3. Okay, next question. Group index of soil ranges such that, group index of soil ranges such that, the options are GI, means group index, less than 20, GI is between 0 and 20, not including 0 and 20. Third option, GI ranges between 0 and 20 including 0 and 20, that is GI is more than equal to 0 and less than equal to 20. And the last option is GI is less than 15. I repeat the question. Group index of soil ranges such that group index less than 20, group index is more than 0 and less than 20, group index is more than equal to 0 and less than equal to 20, or group index is less than 15. Okay. Next question. Yes. Activity of clay is, the options are degree of disturbance due to remolding, measure of the water holding capacity, decrease in volume due to increase in moisture content, or regaining lost strength with time. I repeat the question. Activity of clay is degree of disturbance due to remolding, measure of the water holding capacity, decrease in volume due to increase in moisture content, last option is regaining lost strength with time. Okay, last question. This is a numerical based on the hydrometer analysis of fine grained soils. So the question is, you can write down the question or take a screenshot, like whatever is you are comfortable with. The question is, dry soil sample of mass 50 gram is dispersed in 1000 ml of water. The specific gravity of soil solids is 2.65 and the viscosity of water is 0.0017 Newton second per meter square. The center of the hydrometer is 210 millimeter below the suspension surface. Now there are three questions attached. Determine A. Terminal velocity of clay particles taking 0.002, that is, I believe I will not say which particle. I think you have got the answer already of one of the previous questions. Take 0.002 millimeter as effective diameter. Part B is time of taking the hydrometer reading from the start of sedimentation. Okay, so the center of the hydrometer is taken as the reference point from the suspension surface. So when it is there, that is the time when we take the hydrometer reading. Okay, and part C is percentage of clay particles if the corrected hydrometer reading is 11. Now there is a corrected hydrometer reading which is used to find out the actual number of clay particles deposited at the center from the suspension surface. So what is that percentage if the corrected reading is 11? So I'll repeat the question once. The dry soil of mass 50 gram is dispersed in 1000 ml of water. The specific gravity of soil solids is 2.65 and the viscosity of water is 0.0017 Newton second per meter square. The center of the hydrometer is 210 millimeter below the suspension surface. Determine, part A is terminal velocity of clay particles. You have been given the effective diameter. Part B is time of taking the hydrometer reading from the start of sedimentation. It means time of taking the reading when it reaches the soil particle reaches the center of the hydrometer from the suspension surface. Now part C is percentage of clay particles if the corrected hydrometer reading R is 11. Okay, I believe the question was clear. You can start solving. It is 6:53 right now, so I guess I'll start discussing the solutions after how much time? I guess 15 minutes will be okay with you. So at 7 I'll start at 7:08. Okay, 8 minutes till past 7. Is it okay with you, or you need more time? How many people are there? 5 people. Samitinjay, Dhiraj, Dilshit, Prajwal, Tejabat. So can I start the class at yes, yes. You want to say something, Samitinjay? Okay, I can't hear you. You can drop the message in the chat box.
You can start. You will start at 7. At 7.
Yes, I'll start at 7:08 to 7:10. Okay, you take your time and solve these questions. Okay, but stay in the meeting. Yes, yes, 7:10. 7:10. Okay, Samitinjay wants to start the class at 7:10. Okay, fine. Take your time and solve these questions, but stay in the meeting. I'll start discussing the solutions from 7:10. Okay. Hello. I believe you have solved the questions. How many people are there? Okay, five of you are still here. Yes. Shall I start discussing the solutions? You raised a hand. You want to ask something? Dilshit, or you want to say
No,
that?
no, no, no.
Okay, okay. So I'm starting to discuss the solutions. Okay. All right. So the first question was, just a moment. Yes. The first question was, in case of silts, the following type of soil structure is exhibited. Any answer? Can anyone tell me the answer of this question? I think someone said something, but I couldn't hear. Okay, anyway, the correct answer is honeycombed. Okay, silt and fine grained sand, they exhibit honeycombed structure. Uh, if you can tell me which soil shows single grained structure, which kind of soil? Which kind of soil shows single grain structure? Yes, Samitinjay.
Well graded, well graded.
No, I'm talking about fine grained or coarse grained soil.
Coarse grain. Coarse grain.
Coarse grained soil. Yes, yes. Okay, you can mute yourself. Yeah. So coarse grained soil generally they show single grain structure. Okay, coarse grained soil. Specifically, coarse grained sand and gravel. Okay. Floccular structure. is shown by clay. Okay.
Clay.
Yes, clay. And dispersed also shown by clay. It is after disturbance and fixing, that is
Silty clay.
remolded clay. Okay, it's shown by mainly remolded clay. So there are other soils also which show this kind of dispersed or flocculent structure. Mainly, you know, the main type of soil, fine grained soil, coarse grained soil, silts, clay, sand, and gravel. Among these, I'm asking. So silts show honeycomb structure along with fine sand. Okay. Coarse grained soil, they show single grain structure. Remolded clay, they show dispersed structure, and clay shows flocculated structure. Okay. I hope the solution was clear. Next question. Yes. The biggest size of a clay particle is, what is the answer?
0.075 mm.
No, it is wrong. Anyone else?
2 micron.
2 micron means which option among these?
0.00.
0.002, right? Yes, this is 2 micron. And what I think someone else said 0.075 mm. This is 75 micron. This is the size of what? Silt.
Silt.
Maximum size of silt. Yes, maximum size of silt. This is a boundary which separates fine grained soil from the coarse grained soils. Okay. So 2 micron is the biggest size of a clay particle, and 2 micron means 0.002 millimeter. Okay. Other two options 0.003, 0.0002, they does not have any significant regarding the boundaries forming the maximum soil sizes. Okay. Next question. Yes. Silty clay indicates. What does silty clay indicate? Yes.
Both the proportion are same.
Proportion are same. I believe it's a wrong answer.
Silt percentage is more than that of clay.
Silt percentage is more than that of clay. Again, a wrong answer. So I think only one option is left. And who has message? Option 3. No. So which option is left right now?
Silt percentage is less than that of clay.
Yes. Why? Because see, this silty clay, it acts like an adjective. Okay. The soil is clay. Please mute yourself. Whoever, I think someone's mic is on. Yeah, thank you. So the soil is basically clay. Okay. The soil is basically clay which has silt. That's why it is silty clay. The nomenclature is simply like, for example, color. Okay. Color. There are two colors, blue and green. You can see green, but it has a bluish tinge. So a bluish green. If it has blue color with a greenish tinge, greenish blue, like that. So the fraction which is less will be always in the front. Okay. Which describes the type of the second soil. So the main soil, the basic soil is clay. Silt percentage is less than clay. That is why it has been used as an adjective to the clay soil. And as per nomenclature, this is the rule. Whichever particle will be in less amount, that will be placed in the beginning. For example, if it is clay and it has some sand particles which is less than clay, so it will be sandy clay. If it is sand, it has some clay particles, clay sand. Okay. So clay over here is the main soil. Silt is less than clay, so it is silty clay. Clear? Any doubt? Okay. So silty clay indicates that silt percentage is less than that of clay. Okay. Next question. It's okay if your answers are wrong. There is no worries because you have solved them. That's an important thing. Okay, sand particles are made up of. What is the answer? Sand particles are made up of. Rock minerals. Yes, rock minerals. Yes, Dilshit. You can say or you can type in the chat box, okay? Because I am in the PPT screen. I cannot see all the time if anyone is raising the hand. So sand particles are made up of rock minerals. Name some rock minerals. Can you name some rock minerals? Quartz, feldspar, yes, yes. Silicate minerals, carbonate minerals, okay, like calcite, dolomite. These are some rock minerals. So, what are kaolinite and illite? What are kaolinite and illite? Yes,
Clay minerals. Clay
clay
minerals.
minerals. Yes, clay minerals. Very good. Kaolinite and illite. They are clay minerals. I guess we have another question regarding clay minerals. So, yes, sand particles are made up of rock minerals. Next question. Yes, among the given soils, the specific surface is the highest for. What is the answer? If you don't know the answer, you can tell me. I'll discuss it anyway.
Gravel.
No, you're going from the opposite side, I believe. D. What is D?
So clay. So
Yes.
clay.
So clay. Yes. So you took it as a hint. Good. Clay is the correct option. Why? First of all, tell me what do you mean by specific surface? What do you mean by specific surface? Surface area, only surface area. How can surface area be, highest or lowest for a soil? How can I, compare soil based on only surface area? With respect to volume, not volume, it is mass. Okay, it is mass. Tejabat Ashok. Nice attempt, but it is mass. Okay, specific surface is surface area per unit mass. Okay, so for a given mass, clay has the finest particles. It will have more number of particles, isn't it, for a given mass? For example, take 1 gram of every soil, sand, silt, gravel and clay. Clay will have the most number of particles, isn't it? Because it has the finest particles. So more the number of particles, greater will be the surface area, because each particle will have a particular surface area. More the number of particles, more surface area. Obviously gravel will have larger size particles, but the number of particles will be so high in clay that the surface area will be more for a given mass of soil. Okay, and since surface area is the highest for the given mass, that means specific surface is the highest. So it goes like this: specific surface, clay will have the maximum, followed by which one? Silt, isn't it? Followed by it will be sand, followed by it will be gravel. Okay, so Among the given soil, clay will have the highest magnitude of specific surface, which means surface area per unit mass. Clear? Okay. Next question. Adsorbed water on a soil particle imparts. What is the answer? Adsorbed water on a soil particle imparts. What is the answer?
Plasticity.
Plasticity. Yes, very good. Plasticity. So what is adsorbed water? What is adsorbed water? Water present on the surface.
Water
Attached.
content surface.
Yes, water attached. Who's this? Tejavat, drained water by gravity. No, not drained water. Adsorption and absorption are two different properties. Adsorption is similar to absorption. Here, the water is not, absorbed inside the soil mass, but it is adsorbed means it is attached to the soil surface, the particle, the surface of the soil particle. So in this case, if it is attached to the soil particle, that means that can be easily deformed. Okay, that can be easily deformed or molded. So basically, friction and shear strength, these are the strength properties. With addition of water, the adsorbed water might increase and friction will decrease, and if friction decreases, the shear strength will also decrease. So adsorbed water can never impart friction nor shear strength. Okay, plasticity is the deformability of the water of the soil, which increases. Plasticity increases with increasing water content. That means both absorbed and adsorbed water has impact on the deformability of the soil. So yes, the answer is correct. The adsorbed water on a soil particle, it imparts plasticity. The soil can be easily deformed and becomes plastic in nature. Okay, it can be easily deformed. Permanent deformation can occur after that. Okay, I believe the answer was clear. Next question. Yes. BIS soil classification, that is Bureau of Indian Standards soil classification, is based on. What is the answer?
Both of the above.
Both of the above. Anyone else with any other answer? Yes, both of the above, because obviously grain size distribution will have the first, first step, because we need to understand which type of soil it is, first of all, but also the Casagrande's plasticity chart modified by the Indian standard system, that also plays a role. Okay, and that chart, in that chart, the soil is classified, the soil is separated based on the plasticity properties. Soils having medium plasticity, low plasticity, high plasticity, okay, divided by the A line and two vertical lines. Okay, I'll show you the graph. So yes, the answer is right. BIS soil classification is based on option C, both of the above, both grain size distribution and plasticity properties. Okay. Okay. So next question. Yes, boundary classification is to be resorted for coarse grain soils when the percentage fines is. What is the answer?
It's none of the above.
No,
Greater than 12?
no. Okay, then there is no need to guess, I believe. I'll tell the answer. Wait. Yeah. So the answer is between 5% and 12%. Why I'm saying you? Okay. Suppose we have gravel. Okay. It is G. Okay. According to the classification of Indian standard system, if the percentage fines in this soil gravel is less than 5%, then we do not consider, I repeat, we do not consider the fine particles, the finer size particles in the nomenclature. In that time, we go by saying whether this soil is well graded or poorly graded. So if it is less than 5%, our nomenclature will be, if it is gravel, our nomenclature will be either well graded gravel or poorly graded gravel, something like this. Okay. Now, if the percentage fines is greater than 12%, then we have to take the finer particles in the nomenclature, and at that time the finer particles will dominate the nomenclature more than whether the soil is well graded or poorly graded. So if it is gravel and suppose we have silt or clay which is more than 12% by weight, okay, so at that time we'll write it like this. If it is clay, we can write clayey gravel like this. As I've said, the clay percentage is less than gravel, but the clay percentage is more than 12%. Okay, so it is clayey gravel. If it is silt, then it will be GM, silty gravel. Okay, now what is boundary classification? When this percentage fines, that is, suppose gravel or sand we have, then clay and silt is present, but the percentage of them by weight is between 5 and 12%. Suppose it is 7 or 8%. Then we have to take both the gradation of the soil and the percentage fines into the nomenclature. And at that time, suppose it is the gravel is well graded gravel and the gravel have silts which is 8% by weight. So 8% falling between 5 and 12%, then we'll write like this: well graded silty gravel, well graded silty gravel, and this is called boundary classification. This is called boundary classification for the coarse grain soil basically. Is it clear or do I need to repeat? Is it clear, everyone? Please repeat. Okay, fine. So suppose it is a coarse grain soil. Okay, it is a coarse grain soil and you have gravel. Gravel is the coarse grain soil, G. Okay. Now the gravel also has finer size particles, that is silt or clay. Now the weight of the silt or clay is less than 5%. Less than 5%. Then we will not take the silt or clay percentage into consideration while naming the soil. We'll just go with the gradation, whether it is well graded or poorly graded. So if it is less than 5%, percentage fines less than 5%, we can say if the soil is well graded, GW, well graded gravel, or it is poorly graded, GP, poorly graded gravel. Okay, first scenario. Suppose the percentage fines in the coarse grain soil, that is gravel, it is more than 12% by weight. Then we have to take the finer particles, that is clay or silt, in the nomenclature. Okay, then we cannot write whether it is well graded or poorly graded. We have to write what percentage, what finer particles it contains, whether it is clay or gravel. So suppose this gravel contains clay and the clay percentage is more than 12%, then we'll write GC, that is clayey gravel. And suppose it contains silt and silt percentage is more than 12%, then we'll write GM, silty gravel. Okay, so these are the two extremities. Now if this percentage of clay or silt, that is silt or clay, this percentage, it is between 12% by weight, between 5 to 12% by weight. Okay, then what can we do? In that scenario, we have to take both the gradation and the finer particles into the nomenclature. Suppose the gravel has silt, that is M. The percentage of M is 8% by weight. So 8 is falling between 5 and 12, and suppose the gravel is well graded. At that time we will write like this, we will write well graded silty gravel, GWGM, that is well graded silty gravel, because the percentage of silt is falling between 5 and 12%, and this is called boundary classification. Okay, I hope it is clear now. Okay, fine. Next question. There is simple question. Organic soils have a color of dark blue to ochre. True or false? It is false, because the color of organic soil varies from dark grey to black. Sometimes it can be dark brown also, but generally dark grey to black. Okay. So this is false. Organic soil has a color of dark grey to black. Okay. Next question. The soils which plot above the A line in the plasticity chart are. What is the answer? What is the answer? Okay, let's see the graph. Plotting above the A line. This is the A line. This is the A line. Okay. Above the A line, what do we have? C, it is clay. Okay. Below the A line, we have O, organic soil, and M, silt. So above we have inorganic soil, below we have organic soil. Above we have clay, below we have silt. So above the A line we have inorganic clays. Okay. Above we have inorganic clay. Organic clay, do we have organic clay? We don't have. We have organic soil over here, which is silt. Okay. Organic soil is basically, the third option is basically any soil in this portion, the below the A line. Okay. So above the A line, what do we have? We have inorganic soil and we have C, that is clay. So above the A line, we will write inorganic clay. Okay. Soils is plot above the A line. Okay. Now next question. Soil has a liquid limit 20% and plastic limit of 14%. The soil is as per IS classification. Has anyone solved this question? Okay, so liquid limit, someone say something. 3, option 3, inorganic clays and silts of low plasticity. Yes, correct answer, I believe. I'll just solve it. Liquid limit 20%, plastic limit how much? 14%. So plasticity index is liquid limit minus plastic limit, isn't it? 6%. Okay, now 20% liquid limit, 6% plasticity index. We'll go here. This is a liquid limit, 20% liquid limit, and this range, the shaded region, it falls between 4 to 7. 4 to 7. So 20 is a liquid limit. If you go up, 6 falls here. And what is this region? This is inorganic soil, obviously inorganic soil. C and L, boundary condition, clayey and silty soil with L. L means C and M, clayey and silty soil, and L means low plasticity. This line of liquid limit less than 35 is low plasticity. Between 35 and 50, it is intermediate plasticity, and above liquid limit 50, it is high plasticity. So it is below 35 percentage, so it is low plasticity. So above the Li, that is inorganic soil, C and M means silts and clays, L means low plasticity. So inorganic soils, inorganic clays and silts of low plasticity. Right answer. Is it clear? Okay. Next question. If the soil retained on 75 micron sieve more than 50%, the soil is fine grained. Very easy. What is the answer? True or false? Someone has, yes. Yes, false. It is obviously coarse grained soil because 75 micron is the boundary separating the fine grained and coarse grained soil. If the soil has more than 50% of its sample, that is more than the particle size is more than 75 micron, then it is a coarse grained soil. Someone has their mic on, please mute yourself. Yes, so the answer is false. Okay. Next question. The phenomenon of regaining lost strength with passage of time under constant water content is called. What is the answer?
Liquefaction.
Regaining lost strength. It cannot be liquefaction. It is a detrimental phenomena. Liquefaction. Talking about regaining lost strength. Thixo. Why using short form? Thixo.
Okay, okay.
It's a nickname for thixotropy. Thixo. Someone has written only Thixo. So yes, your option is right, but thixotropy you should have written. Anyway, thixotropy, it's okay. Yeah. So thixotropy is the correct answer. What is sensitivity? Sensitivity is the degree of disturbance due to remolding. Okay. Liquefaction. Someone said liquefaction. It's the loss of strength.
Yeah, I
Strength
got it.
in,
Lots of time. Not,
yeah,
I
it
am
is.
not right.
Yeah, regaining lost strength is thixotropy. The loss of strength and stiffness because of saturation, it can also occur during seismic events, this liquefaction. Okay, and activity I won't discuss now because I have a question, I believe at the end regarding activity. I will tell then. Okay, so the phenomenon of regaining lost strength with passage of time under constant water content, it is called thixotropy. Okay, next question. The predominant mineral responsible for shrinkage and swelling in black cotton soils, what is the answer? I believe many of you. Yes, Montmorillonite.
Montmorillonite.
Montmorillonite. Very good. In black cotton soils, we find Montmorillonite more. That means it is. That's why it is responsible for shrinkage and swelling. Now, among these, which are comparatively stable minerals? By stable, I means they have almost no interlayer swelling. There is no interlayer swelling in two among these three other minerals. There is
Kaolinite.
yes, kaolinite and halloysite also.
Halloysite.
Yes, there is no interlayer swelling, and in elite there is very less negligible interlayer swelling. So this interlayer swelling is what causes this shrinkage and swelling in these black cotton soils, and this interlayer swelling is found mainly in this clay mineral Montmorillonite. Okay, so yes, the predominant mineral responsible for shrinkage and swelling in black cotton soils, the correct answer is Montmorillonite. Okay. Next question. A soil has liquid limit 30 percentage. The corresponding plasticity index given by the A line is. What is the answer? You have solved this, I know. Yes, 7.3. Yes, what is the equation of the A line? For the A line, the plasticity index is given by Pi or IP, whatever you write, 0.73 liquid limit minus 20. This is liquid limit. Okay, so 30 minus 20 is 10. 10 into 0.73 gives us 7.3. Okay, I think it's given over here. Oh, I written over here. Okay, yes, IP is along the A line. The plasticity index is 0.73 into WL minus 20. It is just Y equals to mx plus c, straight line equation. Okay, I believe if you use the formula, everyone will get the same answer. So the answer is 7.3. Okay, the formula is plasticity index equals to 0.73 liquid limit minus 20. Okay, next question. Yes, group index of soil ranges such that, what is the answer?
Greater than equal to 0 and less than equal to 20.
Yes, very good. Greater than equal to 0 and less than equals to 20. So group index is a classification system introduced by the Highway Research Board, HRB. Okay, mainly it sees whether the soil is suitable for pavement design, pavement construction. And this group index, the formula goes like this. Group index equal to 0.2a, yes, 0.2a plus 0.005 AC, 0.005 AC plus 0.01 BD, 0.01 BD. What is ABCD? What is ABCD? Anyone tell me the definition of ABCD? If you remember, it's all right, otherwise I can tell. So A and B. So this group index is mainly based on 3 parameters. The first one is percentage passing through 75 micron sieve. The second one is the liquid limit, and the third one is the plasticity index. Okay, so A is basically that percentage of soil passing the 75 micron sieve which is more than 35% and less than 75%. So the value of A will range from 0 to 40. 35 and 75, the range is 40. Okay, what is B? B is that percentage of soil passing through the 75 micron sieve which is more than 15 and less than 55. So it falls between 15 and 55. Here also the range is 0 to 40 because the difference between 15 and 55 is again 40. What is C? C is the numerical value of the liquid limit which is more than 40 but less than equal to 60. More than 40, less than equal to 60. So here the range will be 0 to 20. If it is 40, then 0. If it is 60, then value of C is 20. And what is D? D is that numerical value of the plasticity index which is more than 10 and less than 30. Less than equal to 30. So here also, if it is 10, that means the value will be 0. If it is 30, the value will be 30 minus 10, 20. So you have got the range. The minimum value of all the parameters are 0. The maximum value for A and B are 40. The maximum value for C and D are 20. if you put the minimum and maximum values in the formula, gi equals to 0.2a plus 0.005 AC plus 0.01 BD, you will get the minimum value of 0 and maximum value of 20. Okay, so it falls between 0 and 20, more than equal to 0, less than equal to 20. Can anyone tell me if the value is 20, is it a good soil or a bad soil? If the value of group index is more, is it a good soil or a bad soil? Please check any reference, soil mechanics book, because when I say the group index is more, that means the value of this parameter will be what? More or less? It will be more, right? Hello, am I audible?
Yes.
Yes, so when I say the group index is more, that means the value of these parameters will be more, right? So if these parameters are more, that means there are more number of particles which is passing the 75 micron sieve, fine particles. Then for C and D, the value of liquid limit is more, the value of plasticity index is more. The soil is definitely not good, not fit for pavement design, pavement construction. So in group index, higher the value of group index, poorer the soil condition is. Okay, so this thing you should check from your any of your soil mechanics reference book. So back to the question, the group index of soil ranges such that it is more than equal to 0 and less than equal to 20. I believe that the solution was clear. Okay, I'll go to the next question. Yes,
Can you
activity.
repeat that A?
Yes, yes,
Sorry.
yes,
Can you
yes, yes.
repeat that A and B? Can you repeat me that A and B? What is the
Yes, so it is,
range?
you can check the any, I have said any soil mechanics reference book. I follow BC Purnia or uh, Rao, Gopal Ranjan Rao. That is the
Okay.
percentage of soil passing the 75 micron sieve. Okay,
Mm.
so
Mm.
that percentage we take more than 35 and less than 75 percentage
Mm.
in A. Okay, in some
Okay.
cases A can be 0 and B can have some value. Suppose the
Okay.
percentage of soil passing the 75 micron sieve, it is more than 35 percentage and it is falling between 55 percentage. Okay, so A means A, for A this finer percentage finer 75 micron is the criteria for both A and B. Okay, but for A this value will be taken between 35 and 75.
Okay.
Okay, if it is beyond 75,
Mm.
generally will not observe that. If it is less than 35, then B will come into play, where we take the same percentage from 15 to 55. So suppose the percentage passing is suppose how much? Suppose it is 45. Suppose it is 45 percentage. So 45
Okay.
percentage is falling in this range. So A will have what? 45 minus 35 is 10. A has a value of 10 and B will have what? 45 minus 15. How much? It is 30, right? So it is 30. Okay, it is 30.
Okay.
Suppose it is the value percentage passing the 75 micron sieve. Suppose it is 65. 65,
Okay.
then is beyond B, right? It will not have any value because only between this range we can take as B. So only A will have some value. Only A will have a value and the value of A will be 65 minus 35, that is 30. Like this. Okay, is it clear?
Yeah. Okay.
Yeah. Please check and just cross check my explanation with any standard soil
Yeah.
mechanics book. Okay.
Definitely. Yeah. Okay. Okay. Thank you.
Yeah. So now the next question was with the activity. What is activity of clay? What is activity of clay?
Water holding capacity.
Yes, very good. Water holding capacity. Someone else, I believe, have dropped. Okay, see, okay. Water holding capacity. So the degree of disturbance due to remolding, what is it called? I have mentioned in the previous one of the previous question, degree of disturbance due to remolding.
Sensitivity. Sensitivity.
Yes, sensitivity. Decrease in volume due to increase in moisture content. It is called collapse. In collapsible soils, even if there is no external load, okay, you can see that with increase in moisture content, there might be, you know, sudden subsidence, slump might occur with the increase in moisture content. It's called collapse. And what is regaining of lost strength with time? I think we have done this.
Thixotropy.
Yes, thixotropy. Thixotropy. Okay. So this question was about the activity of clay. It is the measure of the water holding capacity of clay. Okay. So the last question was this problem of the hydrometer. I have this one solved. You can see this formula is the Stokes law for terminal velocity. Vs equal to G minus 1. G is the specific gravity, minus 1 into gamma W. Gamma W is 9.81 kilonewton per meter square, divided by 18 into mu. Mu is the viscosity into effective diameter whole square. Now I have converted everything into the SI units, 9.81 kilonewton to Newton and 0.002, I think it was in millimeter, yes, millimeter to meter per second, and the answer we get is 0.0021 millimeter per second. Please solve it and check whether it is right or no. I believe it is okay. Have you solved it? Okay, so this was the solution for the terminal velocity. The second question was time of taking the hydrometer reading from start of sedimentation. So this is the formula, velocity equal to distance per unit time. So time will be equal to distance traversed by the velocity. The velocity is the terminal velocity, okay, and the distance traversed will be equivalent to the distance of the center of the hydrometer from the suspension surface. So the particles, the clay particles, have traversed from the suspension surface to the center of the hydrometer, and using the terminal velocity and that distance, we can find out the time when we should take the reading, taking the center of hydrometer as the standard. Okay, so it is L, that is 200 mm, divided by this, converting into hours obviously. So 16 to 60, we get time equal to 27.78 hours. Okay, so these formulas have some, you know, explanations and derivations. You can check it from the book. I'm just going with the solution. Is it clear? This formula, this is simple, and these two are simple formula. I think you have learned it earlier also in fluid mechanics and all. So the third question was, I believe, percentage of clay particles if the corrected hydrometer reading. So hydrometer reading has some corrections. Once again, please go through the standard books regarding this concept behind the hydrometer problems. So the empirical formula for this, you know, percentage of clay particles taken at the time of the reading is G by G minus 1 MD into R multiplied by 100 for the percentage. So G is the specific gravity, that is 2.65. MD is the dry mass of the dry soil, which is 50. Okay, and R is the corrected hydrometer reading. You solve this, you get 35.33 percentage. G by G minus 1 into MD multiplied by R into 100, that is percentage, we get 35.33 percentage. Okay. Any doubt regarding any question or any explanation? Anyone? Hello. Anyone has any doubt regarding any question or the last question? Okay, fine. Just a moment. I'll just go through because it did not catch up in the OBS recorder. So this was the question of thixotropy. Sorry, not thixotropy, activity of clay. Yes, someone has said. Okay, no sir. This was the activity. Next we move on to this problem. This is the first part. The terminal velocity Vs equal to G minus 1 gamma W by 18 mu d square. G is the specific gravity, gamma W is the unit weight, mu is the viscosity, and d is the effective diameter. We get Vs equal to 0.0021 mm per second. In the second part, we are asked to find out the time of taking the hydrometer reading, time equal to distance traversed by the terminal velocity, where L is the distance traversed equals to 210 millimeter from the suspension surface to the center of the hydrometer. The time we get in hours is 27.78 hours. Next, the percentage of clay particles for the corrected hydrometer reading of 11. The formula is G by G minus 1 MD into R into 100 percentage. G is the specific gravity, MD is the mass of dry soil, R is the corrected hydrometer reading, and the percentage of clay particles we find out as 35.33 percentage. Okay. So I believe the solutions were clear. So thank you for attending the class. We'll again meet on the coming Friday with the fourth problem solving session. Okay. Thank you.
Thank you.